Hi geometry students, welcome back to day 1 of 10.4, and so we're going to spend a couple days on 10.4, which is all about, you can't see it, surface area, and surface area of prisms and cylinders. And we put prisms and cylinders all within the same day or under the same category because they both have two bases. For a cylinder, the bases are just circles, but otherwise we have like a pentagon, a prism, triangular prism, rectangular prism. And they both have two bases, and then what we call this side piece here, or all these rectangles, we call those the lateral areas. So when we're trying to find the surface area of these shapes, you find the area of one base, the area of the second base, and then you add it up to the lateral area. For a circle, find the area of the circle, etc. Find the lateral area. So our plan for today, or essential question for today, let me move this a little bit, is can I find the surface area, oh it's tilted, sorry, surface area of right prisms and cylinders. And I'm using that word right prism for a reason. A right prism in our case is when we have two bases and the lateral area, or these lateral edges, like here, for example, are right to the edges of the base. So the base and then this lateral area have to be at a 90 degree to each other. Otherwise, if it was slanted, or these don't do that, but if I was to like take this base and move it over a little bit and these sides would slant, it would no longer be a right prism. So we're only going to talk about right prisms today, and we are going to talk about the surface area formula. Now the surface areas, I could ask you to find the surface area of this shape without these formulas. And I could ask you to find the area of the triangle, find the area of the triangle, add it up to the rectangles. But there are formulas, and those formulas actually make our lives way easier. And so let's look at the surface area formula for a cylinder and the surface area formula for a prism. These are on your formula sheet. Sorry, I got lots of papers over here. These are on your formula sheet. Your formula sheet right here has surface area. Oh, this marker is not working. Surface area of a prism and of a cylinder. Oh man, you can barely see that there. And so we have right prism, the surface area, the cylinder surface area. It's also on your formula sheet. We're going to write it out here. You don't have to memorize it, but you do need to know how to use it. So the surface area of a cylinder is 2 pi radius height plus 2 pi radius squared. And the surface area for a prism is p h plus 2b. And we're going to kind of unload what some of this is. This p is the perimeter of the base. H stands for height. And this big B, I'm going to try and use a different color over here. That big B stands for the area of the base. So if this was my prism, I would find the perimeter of the base. The base is a triangle, so I'd find the perimeter, multiply it by my height. So the height is that here. So if it was standing like this, it'd be the height. And then I'd have to find 2 of the area of the bases. And that's kind of how that works out for the cylinder here, because I'll also show you the similarities here. Height, well that's your height, we know that. The perimeter of a base, of a cylinder, the perimeter is the circumference. So if I wanted to find the perimeter of a cylinder, I would find 2 pi r, that's the circumference. Or we also call that perimeter of the base. And then we have 2 pi r squared, or 2 area of a base. Well, guess what pi r squared is? It's the area of the base. So it could be argued that you wouldn't even need the formula for a cylinder, because the formula for a cylinder and a prism are exactly the same, but the cylinder one has already been changed and modified for a base of a circle. So these are exactly the same. You don't have to have them memorized. Now let's go and use some of them. Example 1, Here's an example. There is a cylinder with a radius of 6 and a height of 10. And so in this case, we know our surface area formula. The surface area is 2 pi radius height plus 2 pi radius squared. Take a moment to type that all in your calculator. I am going to ask you for 2 different answers right now on your assignment or something. I'd only ask for one. But in this case, the surface area is 192 pi. That is your exact area. That's something that none of us can argue about. And 603.2-ish inches squared, because I forgot to put units. Inches squared. So if I asked for exact, you'd give me the answer with pi. If I asked for rounded or rounded to the nearest 10th or 100th, you'd give it to me in a decimal form. Let's try another example. In this case, we're going to try drawing the cylinder. So in this case, the cylinder is drawn for us. We know that my height is 12, my radius is 4. My suggestion when given a diagram like this is to actually write out H and R. That looks like an N. There we go. Write out H and R so that when I say, hey, find the surface area, you just know exactly what to plug in. 2 pi R. And I don't have to go back to my diagram and look for my radius. I have it right there. My height is 12. Plus 2 pi 4 squared. Plug that all in your calculator and you will get 402.124 centimeters squared. All right, let's look at a triangular prism. So example 3. I'm going to draw a triangular prism. I'm going to do my best to draw it slowly enough so that you can follow along. This is a prism where the base is a triangle, so almost as if I took this prism and I'm going to set it on its side like this. It's like if we were drawing this shape right here. So we're going to draw the triangle and we're going to draw the bases as it comes behind it. Or not the bases, draw the lateral area or those sides. I'm balancing this on a canvas. Let me see, figure it out. Okay, here we go. So these lateral area pieces come out. That part that we don't see, we put as that dashed line. You want all of these to be parallel to each other when you're drawing a 3D shape. And you want the other sides to be parallel. So for example, if I'm drawing this triangle, again over there, I want to use the exact same slope there. And if this is perfectly horizontal, I need this to be perfectly horizontal. If this is perfectly vertical, I need that to be perfectly vertical. And hopefully you have a pretty decent drawing of a triangular prism. So the surface area for a prism is perimeter, height, plus 2 of the bases. And nothing is given, or not enough stuff is given at all, so we got to fill in some of this. You do need to know that this is a 90-degree angle. That's important, otherwise we couldn't do this problem. Or we could, just not with the amount of stuff I'm giving you. You would need more if I did not give you that piece. I have enough to fill out all of this. So let's really dissect what all of this is. I do know my height. My height is 10. My height is not 8. The height of the triangle might be 8, but the height of my shape, I'm going to try and use this again. When I have a triangular prism, the triangles are the bases. So this is kind of like a triangular prism flipped on its sides. If I did this and I just flipped it on its side, and that's what we're looking at. And so when I ask you for your height, that is actually 10. And I need, probably should have put that in black, 2 of my bases, and I also need my perimeter. So if we have our bases, our base is there, or that's also a base over there. Can I find the area of the base? I totally can. The area of the base is 1/2 the base of the triangle, not to be confused with little b times height, right? Big B means the whole base, or the whole area of the base, times the height of that triangle. So the area is 12. And then the last thing we need to do is find the perimeter of the base. It's kind of dark to see. How about we try that? Okay, so we need to find the area of the perimeter of the base. So I need to find that. Take a second to figure out how you would do that. We need to find our perimeter. The perimeter in this case is 8 plus 3 plus something. How do I find this? You're going to use the Pythagorean theorem to find that. 8 squared plus 3 squared is equal to x squared. So take a second to do that. I'm going to take my calculator real quick. I'm going to round to the nearest, because it makes it easy to round to the nearest 10,000. So I'm going to just round to there. Plus 8 plus 3, and I get 19.544 for my perimeter. And I would actually probably just keep that in my calculator, multiply by 10, add the 2 times 12. I have everything I need. It took me a little bit longer for this one versus the 2-cylinder ones because I needed to find all the pieces. But let's plug that in your calculator. I'm going to take a second to do that as well because I don't have that prepared for some reason. 12. All right, and it looks like our whole surface area is 219.44. And I forgot units again. Let's make this meters. Meters squared.